Okay, we're coming back with another episode today, and we're going to be doing logistic regression. A lot of the episodes we've just done, I can actually do this here. Ah, okay. So, a lot of the episodes that we've just done on linear regression have done quite a few tests and making plots to assess the results of those tests to make sure that our regression output was valid. And that's all been on linear regression with standard residuals that vary from whatever difference between our predicted values and the actual percent change ultimately ended up being. But there's a completely different way we can use regression to conduct trading strategy analyses, and that's called logistic regression. Logistic regression is a long way of saying regression on true or false, 0 or 1, a logical gap. And or a logic gate if you're in computer science. Anyway, so what we're trying to do now is instead of forecast the percent change that will happen tomorrow, we're going to try and forecast whether that is up or down. And this is not the only thing you need to forecast. Like there's a bunch of other applications to this logistic regression output. Like you could try to forecast if it is greater than 10% or not, or greater than 3% or not, or if the change tomorrow is any difference between yes or no, you can apply that to a logistic regression framework. Now, logistic regression doesn't work exactly the same way as linear regression, and there's a lot of differences. So I can't just quickly paste our code in and make some quick adjustments, and then suddenly everything we know already extends immediately to logistic regression. So I'm going to be making, I think, 3 or 4 short episodes, similarly to how we did with the linear regression tests episodes, to explain the various tests and analyses and graphical representations of logistic regression over the course of this series. So in today's episode, all we're going to be doing is changing the target variable to be a linear output, which is the percent changes, to a logistic output, which is whether or not the percent movement in however many periods we are interested in seeing is greater than or equal or greater than or less than today's price or the current price. So if we're on the hourly data frame, is the movement over the next hour positive or negative, 1 or 0? Or if we want to do 5 hours from now, is the movement in 5 hours 1 or 0? And we're going to be trying to find a trading strategy that identifies up or down as opposed to forecasting the percent change that it will move. This creates simplicity, but it also brings in a whole other set of knowledge that you need to understand before leveraging logistic regression in any machine learning framework or logical frameworks in any machine learning structure. You know what I mean? Okay, we are going to make me small again. I think this is a good size. Yes. And we're going to paste in our regression code without any of the indicators. So let's go back to our regression anything.ipynb. And I want everything up until the technical indicator. So that includes getting data, loading in the data, defining our global variables. I don't need any of this. I need shift, which is going to be 3. I don't need any of these for now. For now, we're just going to do volume. Volume is going to be our only feature. So we're only going to be looking at volume to forecast whether or not tomorrow's price is a 1 for up or a 0 for down. Now, how are we going to define that 1 or 0? You might remember we have our defined target variable function. I forget exactly what we named it, but let's look in our add target. So let's take this, and instead of our target variable being the period percent change, we're just going to change this name to be target. So instead of all that, bang, target. And this is now going to be the difference between the close plus however many periods in the future is minus the current close is greater than the current close. So if it's greater, then we get a 1. And if it's less than, we get a 0. And I can show you what that looks like by creating a main function defined main, and then our data frame is going to equal get data, and then our data frame is then going to add the target to our data frame. We're going to return the data frame, and then we're going to run the main function. Okay, so what do we have here? I actually want this to be as an integer. So if I wrap all of this in parentheses, and you can do as type int, but I like to multiply it by 1. Whoops. That's my bad. I accidentally left this subtraction in here. It just needs to be this. Very simple. I overcomplicated that a lot. My apologies. So now what we'll have is a nice balance of 1s and 0s. Right. So tomorrow, the close price is greater than the close price today. No, tomorrow the close price is less than the close price today. So 305 is less than 309, so our value is 0. After that, 308 is greater than 305. So tomorrow it receives a 1. And our job is to try and find a lot of information in this data to obtain the information necessary to forecast these 0 or 1, which is hard. But it's easier than trying to get the actual percent change, in my opinion. Maybe that's not an opinion. Maybe that's just an objective truth. Not sure. But what we're going to be doing is regressing on volume and using volume as our one feature to forecast whether or not tomorrow gets a 0 or a 1 using a logistic regression output. Now, the main difference between our generate regression output from our old code and the one we're going to make today is the removal of ordinary least squares from stats models. So let's take this whole function, paste that in here. Now we have stats models.ols. We're going to get rid of ordinary least squares because we no longer have that distribution of residuals the way we used to. We're going to be doing logistic logit. And we don't need anything here. Get rid of all that. And once it's fit, we just want to print the model summary, and I don't want any of this plot either because, again, what we had in the past doesn't extend to logistic regression very well at all. So ypred, and I'm going to get rid of the y predictions for now too. We're going to build on this a lot, specifically for logistic regression in the future, but today, all I want to show you is a slight difference in our regression output. Target is going to be target, and that's it. Strategy we already have defined. Target we already defined as this. Perfect. So let's run this, and I hope we should see a nice regression output if we, of course, add that to the main function data frame equals generate regression output. Okay, so now you can see that the model is logit as opposed to ordinary least squares. And we can already see that the p-values from our model is not exciting. 0.6 and 0.689 for the constant. Not what you want to see. You can see that we're using z instead of t because this is logistic regression. This is a different notation. But again, this probably isn't super helpful for learning people without some visual plots, or at least a more clear representation of what's going on. And that's what's going to come in the future. What we have now in the next episodes are going to be confusion matrices, area under the curve plots. I forget what the actual name for them is called right now, but we're going to be doing. And there's one more that I want. And we're also going to be covering the sigmoid function, which is how logistic regression compresses all of the outputs between values of 0 and 1. All super exciting stuff. We got 3 separate episodes to cover it all. For now, we have the logistic regression output that shows the relationship between volume and price changes tomorrow. We also have, remember from our data frame, close, high, low, open. So let's just add those in too. So do open, high, low, close. And see if any of these have a statistically significant relationship on price changes tomorrow. Let's do the S&P 500 on the 1 day instead of Tesla on 1 hour. And all of their p-values except for the constant and the low price and the close price. Wow. So it looks like these might have a statistically significant relationship on whether or not tomorrow opens when the rest are held constant. So the relationship between 1 day's price information and tomorrow's is forecasted statistically significantly by close price movements when the rest are held constant, which is interesting. But again, we can't quite be sure if this is useful without more metrics just yet. So while these close prices and low prices that we see in our model have p-values that are statistically significant, just because they have an impact that is not random doesn't mean it's useful, and you can tell from the correlation coefficients here. You're adding 0.05 to our odds of being between you're adding or you're multiplying the low and close prices by 0.05 or negative 0.05 depending on what they are for every unit of those variables. And it's not a really big important relationship. Another important thing to note is the pseudo r squared. It's called pseudo r squared because again we're using logistic regression, it's not just r squared, is 0.0009977. That is extremely low, really low, effectively 0. So this model, despite having some statistically significant variables that mean that the results shown are not random, it's not quite useful yet. And to make it useful, we need to add some more important information to our data frame that is not just going to be open, high, low, and closed volume. And that's what we're going to be on a pursuit to discover using some more charts and plots and images that make more sense to you guys in the very near future. So thanks for sticking around. This is an exciting start to the next chapter of using machine learning to build effective trading strategies. I look forward to seeing you in the next episode, and until then, stay sharp.